AC/DC.
What we're going to do today will be AC and DC. Okay. AC stands for alternating current. Okay. DC stands for direct current. Okay. They're both power sources. So, for example, battery will be on DC, and your power socket at home will be on AC. Okay. Provide you with AC current. Okay. So AC, if I sketch a current and a time graph, okay, my AC current would look like a sine wave. So, however, the DC current will be DC will be a more stable power source. Okay, it will be just a straight line. The current doesn't change. Okay, however, the value of the current of AC all changes like a wave. Okay, from minimum to maximum. So, what can we say is in AC? You say in AC the current sometimes can be negative. Right? The value of the current can be negative. So it means the current actually travels in an opposite direction. Okay? So the current is basically vibrating in AC. Now look at DC. Okay? Well, DC means the current travels in only the positive direction. Okay, it will be much stable. Yep, so this is a summary here. Okay, now have a look at this. Okay, normally we draw DC in this form, okay, a straight line, but sometimes we have a strange looking current and time graphs, okay, like this. Now, if I look at this graph, okay, the current is changing. Okay, the current is different, but the current is always positive. Okay, so it means the current is still travels in only one direction. It is DC. It is not stable, but it is still DC. Okay, now let me show you how to draw AC and DC on electrical circuit diagrams. Okay, so the symbol for AC power source will be, there's different ways to do it. It will be something like this, or something like that. Okay, so in your circuit diagrams, if you say the power source has those symbols, the AC. Okay. For DC, it will be much simpler. It will be just looks like that. Okay. Just remember the longer line. The longer line here would always be the positive terminal. Okay. Now let's look at what is the RMS value. Okay, we have RMS value for current and voltage. Okay, so what's happened was we know the current is always, for AC, current would always have a sine wave, okay, a sine wave shape. Okay, so how do we indicate the actual current of that current? So one way to indicate that would be we always use the maximum current there. Okay? We call it the peak current. Okay? Say if the peak current in this graph will be 10 amps. Okay? And of course, a 10 amps AC peak current is going to be different. It delivers different power. It's going to be different than 10 amps AC current. Okay? So in order to make it equivalent, so what we have is we divide the peak current by square root of 2. Okay? And we call that the RMS current. Okay? So what it means a 10 amp AC peak current okay, would have the same effect as RMS value of 10 divided by square root of 2 amps DC current. Okay, okay now so what's happened is, okay, if you say here, okay, this AC current of 10 amps peak value, okay, would have the same effect as a DC current, direct current of 7.8 amps. Okay, so in calculations, okay, when you're doing AC when you're doing AC current or voltage calculations, you're always going to use the RMS value. Okay, the voltage RMS value and the current RMS value. Okay, for calculations. Now, just another thing, yeah, just to make it clear, okay, we also have something to analyze AC. Okay, we also have something called the peak-to-peak value. Okay, the peak-to-peak current of this AC signal will be 20 amps. Okay, it means the peak to the difference between the top and the maximum and the minimum, which is 10 and minus 10, which is 20 amps. Okay, so the peak to peak current will be 20 amps, the peak current will be 10 amps. Okay, it is equivalent as a DC current of 7.8 amps in a circuit.